Continuing on in this section 2.2, next topic is the idea of relative maximum and relative minimum. So we're going to be looking at maximum and minimums. And the definition here of a relative maximum says, if you have an open interval, so again, we're looking at these open intervals using parentheses. If we have an interval on our graph of our function where the y value or the f of x value is greater than all the other y values in that area, in that neighborhood, so not necessarily the whole graph, just in that area, then that represents a relative maximum. So here, this point here would represent a relative maximum. We can see this f of a point, if this is a, or x value, we don't know what it is, maybe it's 2, maybe it's 5, maybe it's 17, we don't know, so we're just going to call it a, that its corresponding y partner, or f of a partner, we can see it's bigger than all the other y values in that area, in that neighborhood, if you will. So that point represents a relative maximum. I'm continuing with my hill analogies from increasing and decreasing. A relative max looks like the top of a hill. So that's another way that maybe you can consider it. In regards to relative minimum over here, the formal definition, the official definition says that a relative minimum exists in an open interval if there's an x value whose y partner is less than or smaller than all the other y's in the area, in the neighborhood. So looking here at the graph, we can see when x is b here, its y value is smaller. So the y here is smaller than all the other y's in this area. So this point here, b, f of b, would be a relative minimum. And it looks like the bottom of a hill, if you will, I don't know what you call this, a valley in between the two mountains. So it looks like on the graph, it's the lowest point before you start to go up again. And from coming down, you decreased, you hit the bottom, the lowest point, and then you start to increase again. With the max, we increased, then we're not increasing anymore, we start to come down, and that's where we have the relative maximum point. So let's look at this example here, and we're asked to find the relative minimums, relative maximums, and then there's a question that's being asked of us. So let's take a look at the relative minimums. So for minimums, if we look at our graph, we can see we're decreasing here. We get here, and then we're not decreasing anymore. We're going up again. So this would be a relative minimum. So how can we describe that? Well, let's go back up to the x-axis here, and we see at that point x is -5. So we have a relative minimum where x is -5, and then we continue to go up, and here, let's skip it for now. That would be a maximum. We go down, and here we see we go down. We don't go down anymore, and we go up again. So this would be another relative minimum, and this happens when x is 0. We go up. We don't go up anymore. We come down. At this point here, we've decreased. We've come down. We don't go any lower. This is the lowest point on our graph before we go up again. So this would also be a relative minimum. And here, our x value here, if we look at our graph, is +5. So if we come up here, x is +5. So we have minimums occurring at these x values. Let's now find the y values. So to describe the point. So looking here, at this point here, we can see coming here to our y function that y is -5. So here our y, or our f of x, would be -5. So the point is going to be -5, -5. So we have, there's the full coordinate pair for one of our minimums. Here, when x is 0, we can see y is 0. So the full coordinate pair describing that minimum would be 0, 0. And then at this point here, when x is 5, we can see that y is that -5 again. So our f of x is -5. So our pair would be 5, -5. So we have the minimums occurring at these x values. These are our y partners, and this describes the coordinate pair for our minimums. So now let's look at maximums. Change the color here. So for maximums, we can see we have one here and one here. These points are top of hills. And looking, we see that we were increasing. We get to this point, we don't increase anymore. We're at the top of the hill and we start to go down again. At this, looking down here at the x value, at the x-axis rather, we can see our x is -2. And let's find the y partner while we're here. When x is -2, our y value is 2. So the point would be described as -2, 2. So there is our relative max. Over on this side of the y-axis, we see we have another top of the hill, if you will, that we are increasing. We get to the top of the hill and then we start to go down again. So that would be a relative max. And here, when we go down to the x-axis, we see x is 2. And then our y value is 2. So our point would be 2, 2. So that would be, a relative maximum. So this graph has a lot of activity to show you. We had 3 relative minimums and 2 relative maximums, which brings us to the last question. Why are they called relative max and minimums? If we were in the classroom, I'd be waiting here now for you to come up with your observations, but being I can't hear you through the video, I'll have to keep talking about this. We call them relative because they are describing activity in a limited area of the graph. It's not necessarily there is no other points greater than these points on the graph. It's that they are the biggest or smallest points on the graph for that particular area or neighborhood. So looking at our examples here, in regards to minimums, these two minimums here, -5, -5, and 5, -5, these are the smallest points in these areas of the graph, so they're relative. These two minimums would also happen to be absolute minimums because our graph continues forever on either side. It's never going to turn around and get smaller again than this. There's no place where there'll be smaller values. So as it turns out, these are relative, but they're also absolute. There will never be points smaller than for this function than these 2 points. However, we can see with this minimum here of 0, 0, this idea of relative. This point here, 0, 0, is a minimum for this area, this neighborhood right around it. However, these points are smaller than that. So this would just be a relative minimum it wouldn't be absolute like these because obviously these points are smaller than this point, the y values, the f of x values. In terms of our maximums, we see we have two maximums here at negative 2, 2 and positive 2, 2. And they are the biggest points in their immediate neighborhoods, in their area of the graph. So these would be relative maximums. However, they wouldn't be absolute maximums because we can see all these points here are larger than this and this, and the graph keeps getting bigger. And then to the left here are y values continue to get larger and larger. So all these values here are bigger than these. So what that implies, as I said, these are not the absolute maximums, but it doesn't negate the fact that they are maximum points, maximum values for these particular areas of the graph.